In this video, we're going to talk about an overview of Bitcoin and the history of cryptocurrencies. This isn't going to be exhaustive, so we'll give some links to a bunch of other material. Now, you probably, if you've heard about cryptocurrencies, you've heard about Bitcoin. This is considered the first successful cryptocurrency. It's over a decade old now. It originated in late 2008, early 2009. And if you don't know the origin story of Bitcoin, it's really fantastic, so you'll enjoy reading about it. We'll include some links below. Basically, this was created and launched by a pseudonymous figure, Satoshi Nakamoto, whose real identity we still don't know today. And this was released with a sort of a political or a revolutionary style message at the peak of the financial crisis. And it was released on a cryptography enthusiasts mailing list with a white paper, some associated mailing list posts, and a zip file of source code for the Bitcoin peer-to-peer network. And the idea of it is to create a new kind of digital money that's run entirely as a peer-to-peer network, isn't controlled by any banks or corporations or governments, entirely a peer-to-peer electronic currency. And the actual functionality that the Bitcoin peer-to-peer network provides is actually pretty simple. It's roughly a shared database that implements a digital currency. So at any given time, this database keeps track of effectively an account balance for everyone using it. Like Alice has 20 units, Bob has 20 units. It wouldn't actually be their real names typically, just some account with an account number. And the units, they aren't dollars. Really, the units aren't anything. They're bitcoins or ether. We'll talk about that later. But they don't really represent anything other than just their entries in this database. And how do you interact with this database? Well, you can transfer money that you own. Like Alice here can send 10 units to Bob. And the database is going to be uploaded accordingly, and Bob will be able to realize that he received these 10 units of virtual currency. Now, what you care about for a virtual currency application are essentially security properties. You want to make sure that if you think that you have 10 units in your account, then that's actually the amount that you have. You don't wake up and suddenly have none of them left. You care about having the system be available. If you want to use this as money, if you want to use it for payments, you want the system to actually be around to be able to process your transactions. Clearly, Alice doesn't want Bob just to be able to reach into her bank account and take all of her money, so there's clearly a goal of access control, like each user should be in possession of their own account. You also, and we'll talk a little bit about this later because not all cryptocurrencies support this very well, you may care about privacy. So your financial records, you probably don't want it in the hands of marketers or advertisers or enemies in general, other nations, hackers, people who shouldn't have access to all of your financial information. And we'll talk about the privacy goal a bit later. Now, even though we think of cryptocurrencies as originating with Bitcoin, basically what the Bitcoin system provides is not an entirely new idea. It's essentially a distributed database. And the point of a distributed database is that it provides some notion of fault tolerance, meaning there's a lot of different participants in the network, not just one computer, no single point of failure. And even if some of the nodes in the network are compromised, like they crash or start running too slow, or the person running them gets hacked into, or their location suffers a flood or something, there's like a fire in a data center holding some of them, a compromise of some number of them isn't going to take down the entire network. So the network altogether acts like one big shared database that everyone can use, and it provides some fault tolerance because it's actually implemented across many different computers. And this idea isn't entirely new. There's a lot more discussion to be had about what goes into the design and the specific security goals of blockchains generally. But most of that is out of scope for this course because we're just going to be using the blockchain as though it were effectively a trusted computer. One point of distinction to make is that while we're going to be looking primarily at Ethereum, which is a permissionless blockchain, there's also other models for how to do a distributed blockchain. So a popular model called the consortium blockchain roughly is when there's still, it's not just open to anyone, there's some fixed or well-regulated set of participants. This makes sense when those participants are generally trusted. What's kind of surprising about Bitcoin and Ethereum is that they're permissionless or public blockchains. They're essentially built on top of peer-to-peer networks that anyone can join the network and begin contributing to it. And in fact, in the case of Bitcoin, and I think these numbers are comparable to Ethereum, you can keep track of the number of nodes that are on the network. It's not really a perfect measure. This is roughly the reachable nodes, like the ones that are on the network and have their ports available to connect to. They're typically nodes you would connect a Bitcoin client to. And you can think of, at the time of this recording, being roughly 10,000 of them, on the order of that for both Bitcoin and Ethereum. And they're distributed around the world, and when they're tracked on maps like these, you could add yourself to this map just by downloading the Bitcoin or Ethereum source code and connecting your node to the corresponding peer-to-peer network. The permissionless cryptocurrencies like Bitcoin and Ethereum are known especially for their mining, their proof-of-work mining way to approach their security guarantees. And this is a bit of an unusual process. We won't go into too much detail about it. It's actually also very complicated to explain. At a high level, the best way to explain it is that although anyone can join the peer-to-peer network to be responsible for committing blocks, like processing and validating each transaction, that's actually a competitive process. And in Bitcoin and Ethereum and other proof-of-work cryptocurrencies, the way you compete in that process is by having computing power called miners, like computing equipment called miners that are performing essentially useless except for the network puzzles. They're essentially doing a brute force search of a problem that's just defined for the sake of having a problem with these characteristics. And basically, someone random wins every 10 minutes in the case of Bitcoin, or around 15 seconds in the case of Ethereum. And how likely you are to be the next winner depends on how much computing power you have. And because miners get rewards in the virtual currency itself, they have some incentive to put more computing power in, except that the amount that you get is sort of divided up among all of the other miners that you're competing with. So it seems like it reaches some kind of equilibrium where people mine as hard as they can based on how much cryptocurrency is put out. At this time, the Bitcoin network, for example, gives a reward in total of about $1 million worth of Bitcoin per day, which gets divided up to the miners roughly in proportion to their hash power. That's really it at a high level. There's a lot more technical detail, but like I said, we're going to mostly be considering mining something that just works for the sake of this discussion and using the blockchain at a slightly higher level. Now let's talk a little bit about how you use cryptocurrencies and the transaction layer. So you may have seen pictures like this. A Bitcoin or Ethereum client is something you can run on a mobile phone, and if you want to send someone a cryptocurrency, you often scan a QR code. So let's talk a little bit about what's actually going on here. So while you can have a phone, like a mobile phone cryptocurrency client, and we'll be working with an in-browser cryptocurrency client called MetaMask, I think a paper wallet is actually the best way to get acquainted with a cryptocurrency. And this is a way that you can give on a piece of paper cryptocurrency as a gift. This is one for Bitcoin. They have them for Ethereum and other cryptocurrencies as well. So the idea of a Bitcoin paper wallet is that it has two things on it. It has your public key and your private key. Now, cryptocurrencies are based on public key digital signatures. This is a kind of cryptography called public key cryptography. And the idea is you generate randomly your private key and your public key at the same time, just by generating these. This is running some computer algorithm. It's like a randomized computer algorithm that makes some random choices. You get basically a 32-byte private key that's a random string, and a 32-byte effectively random public key that's connected to your private key in a way I'll describe. And the idea is that your public key you can share with anyone. This is also called your address. It's basically the public name of your account. Your private key is the credential you need in order to spend money from your account. So the idea is you want to keep your private key safe. In this paper wallet, this is actually meant to be folded up. And I don't know if you can see here, but this is a little speckle pattern so that when you fold it up, you can tape it down or put a foil seal on it. And if you hold it up to the light, you won't be able to see this. You want to keep your private key safe because whoever has your private key can spend your coins. So your wallet is sometimes, your secret key is sometimes called your wallet. Your public key is also called your address. This is true in both Bitcoin and Ethereum. Yeah. So just to summarize, in public key cryptography and in cryptocurrency, if someone has your public key, all they can do is send you money. And if you have your private key, if they have your private key, they can take your money. And if you lose your private key, you no longer have access to the cryptocurrency that was stored on that wallet. So just to put this back in context, the Bitcoin and cryptocurrency networks are peer-to-peer networks, and basically what they're doing is keeping track of mappings from public key addresses to a corresponding amount of digital currency. And what you're doing when you make a transfer from Alice to Bob is you say, transfer 10 units from my account to Bob's, and you include your account in both the sender and the destination account are just described by their public keys, by their addresses. And this transaction message comes along with a public key digital signature on the message to authenticate it. And basically, for this transaction to be valid, the public key digital signature has to be verified according to the public key associated with that account. So the only person in this case who can spend money from Alice's account is Alice, because the only person who has only Alice has her private key corresponding to her public key address. And so essentially what the Bitcoin network is doing is keeping track of all of these transactions and checking all of their signatures and only including valid signatures that don't double spend or create money out of thin air, basically that preserve the balance of the virtual currency. Okay, and so what's happening in that picture with a mobile phone cryptocurrency client? Well, the mobile phone application generated the private key, or imported it. Anyway, it's storing the private key on it. And when you scan the QR code, you're scanning someone else's public key. And that's the person whose public key you're going to pay. And so you scan the public key into your phone. You're aware of your own public key. You have the corresponding private key, so you can sign transactions that send units from your account to theirs. Now the Bitcoin network, the Ethereum network as well, any cryptocurrency network, even though they're implemented as peer-to-peer networks, you commonly go view what the history of transaction is, the current state of the database, by going to a block explorer. And when you go into a block explorer, you see all of the batches of transactions. Again, there's a batch of transactions, a block of transactions in Ethereum about every 15 seconds, in Bitcoin about every 10 minutes. In each transaction, you can look at the details. It has basically a from address and a to address. Those are both public keys, the amount of the transaction, and if you chose to check, you would be able to see the signatures, where the signatures are valid corresponding to the public key. I like this photo a lot because you can ask yourself, who's the intended audience of this? What's this guy showing? And you look at it a moment, well, what's that QR code? That's his address. Right, so your address isn't the keys to your account. It's like a one-way valve. Like knowing someone's address, all you can do is send them money. So this guy's asking, send Bitcoins to this address. And the joke of it is that even though, presumably this is meant to communicate to his mom, the funny joke about it is anyone who sees this address, the only thing they can do is send some money to it. So really he's hoping this gets picked up and people just think that's cute and end up sending money to that address. You can try. I don't know how easy that QR code is to decode. So mobile phone clients aren't the only way of having your private key stored. There's also physical devices, hardware wallets, which are special designed electronic gadgets whose only purpose is to generate a private key on there and have a little screen so that you can preview any transaction you're about to send, so you can check that, okay, you don't have malware on your device. This is actually sending a transaction to the public key and the right amount that you expect it to. Besides hardware wallets and mobile phone wallets, some other ways of interacting with cryptocurrency networks are through cryptocurrency ATMs. These are increasingly springing up in various places. Sometimes you have to provide authentication to them, especially if they're going to give you cash, let you sell your cryptocurrencies for cash. Often they let you buy cryptocurrencies without any identification. All you need is to say, this is the account number, the public key address that you want money to go to, and then insert some cash. So those are pretty cool. I've already been mentioning Bitcoin and Ethereum. Basically, the case is that while Bitcoin is the largest, probably the most well-known, and arguably the first cryptocurrency ever, there's actually hundreds of cryptocurrencies now. You can go view all of them on different websites like coinmarketcap.com. In this course, we're mostly going to be working on the smart contract programming language in Ethereum, but most of the concepts and things about blockchains, how to think about blockchains, apply to all of the cryptocurrencies. as well as largely to private or permission cryptocurrencies, permission blockchains rather too. As I mentioned, the units in the database don't have any particular meaning. They don't represent gold or anything like that. They don't represent an IOU from any particular person. They're just units in a database. And so the only reason why they seem to have any value at all is because people trade them on exchanges. There's a variety of exchanges for cryptocurrencies, like Coinbase and Kraken are just two that I know of. And these will basically allow you to have accounts in dollars or whatever your preferred currency is, and let you buy and trade cryptocurrencies for different prices for each other and for dollars. And these are basically open markets in the sense that buyers and sellers can both have accounts. You can make trades with anyone else who makes a market offer and is willing to accept a trade on that. So it's a market, and the price basically just represents whatever price someone else is willing to pay for it. So it's hard to exactly explain why a cryptocurrency has value. Monetary economics is out of scope for this video series for sure, but roughly you could think of it as they have value because someone else is willing to buy it and thinks it has value. So in this course, we're mostly going to focus on smart contracts. So just to give a little bit of background, I think of smart contracts as the generalization of Bitcoin. So now, instead of just viewing a cryptocurrency as account balances where you can transfer account balances to someone else, really what we're thinking of is a programmable model where we've got this distributed database, the blockchain, and now we're going to, instead of having it just have accounts, it's actually going to look a little bit like a computer operating system, in the sense that this distributed database is now going to keep track of a set of running processes, which are called smart contracts. And each contract comes with a piece of program code. The whole point of this course is going to be about how you program that program code. They also have access to memory or storage, which the program code can interact with. And so it's still a cryptocurrency. You can send and receive these units of made-up currency, but now the program's instances themselves can all also hold amounts of cryptocurrency. It's essentially an account balance with program code attached. And you can not only send money to and from these smart contract programs, but you can also provide input data to configure what they do. And any user can also create their own program code and put it in the blockchain. That's going to be something we do a lot in this course. So smart contracts, they're not really smart, they're not really contracts. All we mean for this course is that they're user-defined programs that are running on top of the distributed blockchain database. Now we're mostly going to look at the smart contract programming model in Ethereum. We'll have a lot more to say about this in the upcoming videos. But in a nutshell, Ethereum presents a programming language called Solidity, which is a little bit like an object-oriented language if you've seen Java or JavaScript even. Each contract is basically an object of a class. As a programmer, you define these classes. You define them as having storage variables, and you define them as having methods or functions which run the program code and interact with the data and with the storage and receive inputs and can send and receive money to and from users and from other contracts. Although we're going to be focusing on actually getting things done in kind of the low level, like how to program this, just at a very high level, the idea is that you want to make useful interactions described in smart contracts. So for example, you can model things like financial risk swap kind of instruments where you say, okay, well, upon some condition, like a certain stock rising to some value at some time, then we're going to assign some units of a digital asset, and someone else is going to have to pay some units of currency or cryptocurrency. So to actually work up to implementing this sort of thing in the smart contract programming language, that's going to require a bunch of techniques that we're going to talk about. And we're not just going to talk about financial instruments like this. There's a whole host of applications like auctions and lotteries, and we'll talk a bunch about those in upcoming videos. While we're here, just want to briefly mention that the important focus of this course is going to be on the security of smart contracts. And despite how revolutionary and exciting this new programming model is, you really need to be aware about the inherent dangers of it. So even though the Ethereum smart contract system has only been around for a couple of years, you may have already seen a bunch of these headlines. Essentially, people have been using it with real money at stake. It's real money in the sense that you can trade Ether on exchanges. So when one of these events occurs, like a disaster due to a bug found in smart contract code, that actually ends up costing people effectively this much money. So some of these headlines are like tens or hundreds of millions of dollars have been lost due to programming accidents or have been exploited by attackers on the peer-to-peer network, taking advantage of bugs and vulnerabilities in the smart contract code. So really the point of this course isn't just to talk about smart contract programming, but really to get you thinking about the issues behind the vulnerabilities and potential hazards and things to look out for and try to avoid and engineer around in smart contract development. So let's recap. A blockchain is just a distributed shared database, and smart contracts are just computer programs that are running on top of this distributed database. Cryptocurrencies like Bitcoin and Ethereum just happen to be applications on this distributed database that act like a digital currency or virtual money. And the digital currency application makes use of public key digital signatures. Your public key is your address. That's something someone can use to give you money. It's the public name of your account. Your secret key is what you need to spend your money to make a digital signature, so don't lose that or you've lost the money. And we're going to mostly be focusing on the smart contract programming in this course.